Okay, so hi everyone, Senan this side, and in this video we are going to see the depth first search traversal of a graph. So in this question we are given that the graph is basically connected and undirected. So we need to perform a breadth first search traversal, and so it is asking for a recursive approach. I'll show you both recursive and iterative. First we'll see the recursive approach, that is straightforward, and then we'll look at the recursive or iterative solution. Okay, so basically this is the recursive function. So I declare the visited array and an answer array, and in the end I return the answer, and I call DFS starting from 0 as it is given in the question. Otherwise I would use a for loop for 0 to v, and I would call for I goes from 0 to v, I would call DFS for I if I is not visited, in the case where graph could be disconnected or not. And how does this recursive DFS work? It basically works as, first, you whenever you see a node, you mark it as visited, right? Since you have not seen it yet, you mark it as visited and make this a part of your answer. So for in this case, first you go to 0, you push 0 into your answer. Now you go to all the neighbors of this node. So basically you go to this one, 2 3 1, and first whenever you go to 2, you call DFS. So you go here, you mark this as visited, you push this into the answer, and then you call for 4, right? After you call for 4, you mark 4 as visited, you push back this into the answer, so 0 to 4 is the part of your solution, and now you backtrack because the 4 has no more neighbors. Again 2, so since 4 is already visited and there are no more neighbors, so 2, the DFS call for 2 is also, now you go back to 0. So the DFS call for 0 is now called for DFS of 3. This is pushed into the node, marked as visited, and you backtrack back to 0 and again go for 1. You mark this as visited, you push back this into the answer, and you're just done like that. Let's say if there are cycles, since you have already visited a node, you won't be visiting them again, so that is why we are using this visited array or this visited. So this is basically the recursive approach. Now we do the same thing, but we would use the iterative approach using a stack data structure. So since we start from 0, so I initialize a stack and push 0 into it. Again we need to have a visited and an answer array, answer for returning the answer, and visited to keep track of all the nodes that I have already visited. Now what I do is, while the stack is not empty, I take out the top element, right? In this case the first element would be 0 and stack is not empty. Take this out. If it is visited, right, if this 0 is visited, so I don't continue, I go to the next iteration. I have already popped this element, right? So this would, if I continue this, the size of this stack decrease by 1. Since 0 is not visited, I would mark this as visited and I push back this into our answer. So 0 is part of our answer. Now I find all the number of children of this node, right? And to do that, I just get the size using this size method of this vector, and rather than pushing 2 3 1 into the stack, I would 1 3 2 in the stack, because after 0 I want to go to 2, then 3, and then 1. But since I'm using a stack data structure, if I push 2 then 3 then 1, so the top of the stack would be containing 1 and not 2. So rather than pushing into the stack by the left to right, I would push from right to left. That is what I'm doing. So while I minus 1, I is greater than 0, I minus minus, and I push the ith neighbor from the behind. First ith neighbor, second ith neighbor, or third ith neighbor, like this. And basically I do this. So let's do a simple dry run for this tree. So first, stack is not empty, stack only has 0. Okay, you pop this element, so st.pop, you store this top element as in this top variable. Now your stack is now empty and you have this element 0 in your hand, and you push this into the answer array. You mark this as visited, right? And what you do is you push 1 3 2 into the stack. So your stack has 2 at the top, then 3 and 1 at. Now after this, I again go to this while loop. I check stack is empty or not. Again, stack is not empty because we just pushed 3 elements, right? So we took out the topmost element, that is 2. I removed it from the stack. So my stack is containing 3 at the top, 1 at the bottom, and I have this 2 in my hand in this top variable. Now what I do is I push all the children from right to left. Since there is only 1, I push 4 into the stack. So my stack is now containing 4, 3 and 1. Now after this, for loop, I go again, check this while condition again. My stack has 3 elements, it's not empty, the topmost element is 4. Okay, so I visit. Okay, so I take the top element here, I pop the top element, I mark that as visited, and I push back this into the answer. So my answer is now containing 0, 2 and 4 as my answer. Now since 4 has no neighbors, I just don't go inside this for loop, right? Now again I go to the while loop, check the condition. Now the topmost element is what? I take the top element, I pop that element, I mark that as visited, I push that into our answer, and I push all the children which are not existing. So we don't go into this for loop for this case as well again. So now at this point of time our stack only has a single element, that is 1. Now what I do is I again check this while condition. Stack is not empty, obviously it has 1. I take out the top element, I pop the top element, now stack is empty, I mark that as visited, right? I push that into my answer. So my answer is now having 0, 2, 4, 3 and 1. And now for all the children of 1, I just push that into the stack. Since there are no children, stack is still empty and will remain empty after this. After this I go again, I check the condition in the while loop. Now stack is empty, so I just get out of this while loop and I just return the answer. So that is the answer, 0, 2, 4, 3 and 1. That is what we got. So that is the whole point of this video. Hope you understood it. If you liked it, if you understood something, please make sure to share it with someone who you think might find this type of videos useful. And yep, thanks for watching.